Mining is one of the earliest and most important applications of practical geology. Mining has been going on for thousands of years. The oldest gold mining began over 6,000 years ago. The first gold coins were used in Turkey in 550 BC. But with the development of new technologies for both recovering metals and developing uses for them, the mining industry is an important component of the economy. As I have said before, if it isn't grown, it's extracted. What's also worth knowing is that if you're interested, you can mine too. Gold mining is something that a weekend geologist can explore. Let me give you some background first. Metals are traditionally divided up into two broad categories: base metals, like iron, and precious metals, like silver and gold. Most metals are found in igneous and metamorphic deposits. This is as true of base metals, like tin and lead, as it is of precious metals. For base metals, for the most part, mining has moved on from the traditional underground mine and been replaced by huge open pit mines like Bingham Canyon Copper Mine in Utah, the largest human-made excavation on Earth. Precious metals are not just metals that are expensive, although precious metals like gold, silver, platinum, and palladium are indeed expensive. Rather, precious metals have four characteristics. The first is that they are scarce. For example, the abundance of palladium in the Earth's crust is about 15 parts per billion. Platinum, 5 parts per billion, and gold, 4 parts per billion, are even less abundant. The USGS estimates that the total volume of all known gold in the world is only 244,000 metric tons. The other characteristics of precious metals are that they are solid, they're non-toxic, and they're durable. The distinguishing characteristics can be a little arbitrary. For example, copper. Frequently, copper is mentioned among the precious metals, but it tends to be worth only 10 to 30% as much as silver, and it has a high melting point more typical of base metals. So if precious metals make up such a small percentage of the Earth's crust, how have people been locating significant amounts for so many years? Gold is one of the 20 or so native elements that can sometimes be found in a pure state without being mixed in an ore. And because gold's pure form doesn't tarnish, it remains shiny and relatively easy to identify. Now, in most cases, metals, including gold, occur within the mantle and are brought to the Earth's surface. That happens through igneous or metamorphic processes. You know about one of the igneous processes that brings metals to the crust from the discussion of gems. Pegmatites, which form during late-stage crystallization of igneous bodies, result in some spectacular formations of rare earth metals. An example is in the Bokan Mountains in the southeast panhandle of Alaska. Hydrothermal processes associated with igneous rocks also generate precious metals. Hot water, either directly from magma or in contact with magma, will concentrate metals like gold and silver in veins as it moves into surrounding rock, like in Cripple Creek Mine in Colorado. That began operations in 1890, and they continue today. These hot fluids often, but not always, contain sulfur. In Sweden, dogs are trained to follow the smell of sulfur in recently deposited glacial sediments as a way of finding precious metals in the mountains where the glaciers flowed from. Another volcanic process that concentrates precious metals is crystal fractionation and settling. As a body of magma crystallizes at depth, very dense minerals will settle out first. There have been alternative models of formation suggested, but this seems to be the mechanism of the development of the ores of the Bushveld complex in South Africa. This is the largest single igneous body on Earth, and its products include chromium, nickel, vanadium, and platinum. Precious metals are also concentrated by metamorphic processes. Tungsten and molybdenum are produced in the eastern Sierra Nevada of California as the result of contact metamorphism. Metamorphic hydrothermal processes result from the heat generated by pressure to concentrate gold and silver. The gold rush of the California Mother Lode is a gold belt at least a mile wide and 120 miles long, which are the result of hydrothermal processes. So those are the processes that get metals up to the Earth's surface, and certainly many metals are mined in those hydrothermal, igneous, and metamorphic bodies. In fact, a frequent theme in movies is the old miner digging in a mine shaft, searching for the mother lode. In those highly romanticized scenes, miners will follow a vein in hard rock looking for gold or silver. But frequently, ores, concentrations of metals that are profitably extracted, are created by surficial processes, weathering, erosion, and river transport. These are called placer deposits. If it's an ancient river sediment, it's called a paleoplacer deposit. Placer deposits are where you can find precious metals. Let me tell you about how it's done. Another common image from movies is the miner searching for gold while wading in a river with his gold pan. This method of mining is called panning for gold. Gold is resistant to weathering. Under normal conditions, weathering processes will break down the rock that's around the gold, but the gold will be unaffected. Eventually, both the weathered host rock and the gold will be washed into river channels by running water. Because it is denser than clastic sediments, gold is left in the stream bottom as other sediments are transported away. So that's where you look when you start panning for gold. Panning for gold is a straightforward process that uses the principle of sedimentation, the same principle that puts the gold in the river in the first place. Dense particles settle to the bottom. Finer particles are washed away. What do you need? Not much other than a shovel, a bucket, a coarse sieve, and a gold pan. Oh, and bring a stool. Bending over like you see in the movies is for the birds. You will hurt your back. Get a small collapsible stool that can get wet. If anybody laughs at you, just tell them a cotter told you that all the pros used the stool. Now all you need is a river. Which one do you pick? Certainly not all rivers have gold in them. If you're aware of the local geology, knowing where igneous rocks and hydrothermal activity has occurred helps. But the fact of the matter is, the best place to look for gold is in rivers that have been yielding gold in the past. If there was once gold found in a river, there is a very likely chance that there will be more gold there. So essentially, you're looking at mountain rivers of the Appalachians or the Western states, and a little bit of history research will help. You also have to make sure that you're not occupying someone else's claim or the river you've chosen has laws prohibiting panning. You also have to watch out for private land, both in terms of access to a location and the streams themselves. It can be a complicated process, but for strictly recreational panning, many streams can be accessed. Frequently, state agencies will have information about what is legal and where you can pan. One of the best ways to start out is to head out with somebody that's done it before, or you can join a gold panning club. It's safer and you get free advice from people with similar interests. Also, before you start, make sure you know the depth of the stream you'll be walking in and get a sense of how fast the current is. Mucking around in streams can be dangerous, so please be careful. So check off all the boxes. There is a history of gold mining in the stream you've selected. You are allowed to pan there, and you have your equipment. Here's how it's done. Start with a bucket of sediment. Where do you dig it from? For your first time, you might want to just use sediments from the river bottom, close to shore. So, dig a shovel full of sediment and pour it through a sieve into your bucket. Pick out the bigger chunks in the sieve and toss them, if they're not gold nuggets that is, back into the river. Repeat until you have a pretty good bucket full. Now, bring the bucket over to the shore, sit down on your stool, and shovel some sediment out of the bucket into your pan. Make sure everything is nice and wet. So the principle we're going to exploit is that dense particles will make their way down to the bottom of our sediments. You shake the material in your pan vigorously, and you have to make sure it's wet. I have a pan full of sediment. As the pan is shaking, if there's any gold, it should be making its way down to the bottom. Using a shallow angle, dip the edge of your pan into the river. That lets the current wash away the topmost sediments. As you can see, those will be small particles of silt and sand. You just need to be sure you vigorously agitated the material in your pan. That way, the gold will sink to the bottom. It's the other material that washes away. Now you just repeat the process. Shake the pan again and again. Swirl around the sediment to loosen any material, but make sure that the particles are mixing and the gold has space to work itself down. Now, dip the tip of the pan in the water again, and again, wash away the uppermost sediment. At this point, you can be picking out the coarser grains. When you get down to the last cup or so of sediment, swirl your pan and tilt the pan backwards a little bit so that the remaining sediment just barely covers the entire bottom of the pan. Now, see if there are any little flecks of gold. If so, you are officially a gold miner. Be careful to remove those little flecks and make sure you put them in a safe spot. They can get away from you by water currents or wind. Some folks use a little aspirator to suck up the little grains and make it easier to get it out of the pan. But that's the way it's done. Two more things to keep in mind. First, you do need patience. It's a slow process, but don't spend too much time on that last little bit of sediment in the pan. If there's any gold, you'll see it and be able to pick it out. No need to spend time washing every other particle out of your pan. As you're about to leave, take a look at the stream. You can tell right away where the issues are with placer mining. One, you're mucking around in the stream. That can't be good for either the stream banks or any critters you're tromping on. Second, you're putting suspended sediment into the water column. Any organism passing water through their gills is going to be a little put out by that. It's easy to see why panning is illegal in some streams. It may be that placer deposits were how gold was first discovered. I mean, here are these gold flakes and nuggets on the bottom of a stream bed. It's easy to imagine people finding stuff and quickly recognizing that it's an interesting metal. Over time, people realized gold is both extremely durable and malleable, and as a result, highly desirable for many uses. As demand for gold grew, so did the scale of placer mining. The object of all commercial placer mining operations is to process more sediment. This requires higher volumes and faster flow rates of water to wash the stuff. That's how placer mining technology developed. Initially, it was a matter of diverting streams and creating sluiceways. Wooden troughs with cross slats would collect the gold as the sediment washed on down. Then came the development of hydraulic mining, high-pressure hoses that would blast water into the sides of streams and terraces, washing down sediment by the thousands of cubic yards into bigger and bigger sluiceways. The environmental havoc was obvious. The sediment clouded up streams, clogged up rivers further downstream, and clogged up irrigation systems, which ruined farmland. In the U.S., almost all hydraulic mining was outlawed by 1900. However, hydraulic mining did continue in the Amazon basin, as well as a couple other parts of South America, even into the 21st century. Then came the development of the gold dredge. Essentially, a dredge was a barge with a sediment processing plant built right on top of it. At one end was a long sluice, up to 90 feet long. Sediment was shoveled into it. The barge's pumps would wash the sediment down through the center processing plant, and then the waste sediment was shoveled out the back. These barges would work their way upstreams, removing the land on the upstream side, and then piling up the processed sediment behind it on the downstream side. The Yankee Fork Dredge in central Idaho is one of the best preserved examples of a gold dredge, and you can go visit it. The approach is by a typical mountain road. There's a scenic, narrow stream and tree-covered slopes. It's great stuff. But once you get north of Blind Creek, things begin to change. The valley opens up. There's a much wider river bottom with lots of exposed sediment. And if you look carefully, the sediment has an interesting pattern to it. 6 more miles up is Yankee Fork Dredge. It is absolutely amazing and a little bit surreal that this 4-story barge is sitting there 6 miles up from Blind Creek. What they did when construction started in 1940 was to haul pieces of the barge pontoons and the engines up to Blind Creek. They then built a dam on the Yankee Fork and ponded up about 11 feet of water. Then they constructed the barge and started digging upriver. The barge's shovel would excavate up to 7,000 cubic yards of sand and gravel per day. The sediment went through the various tumblers and sluices in the barge, giving the gold a chance to work its way down into the hold, and then they threw the tailings out the back end. The pond that floated the barge moved with the operation. The gravel that was left behind continually made a new dam. The patterns in the gravel you see today represent the sequential dams that followed the operation upstream. The total cost of the dredge was not quite $500,000. It operated from August 1942 until June 1953. During the decades that it operated, it generated over $1 million worth of gold and $14,000 worth of silver, which would be worth much more today. And on the day it shut down, the owners just walked away. Eventually, it came under the ownership of the state forest, which is why it's still one of the best preserved gold barges in the country. Try to check it out sometime. With changes in technology, gold mining has evolved beyond panning, power washing, and dredging. Instead of placer mining, now gold mining is all about processing hard rock. In fact, one of the biggest gold mining booms in history started around 1985 and continues today. Of course, unless you're in the industry or an investor, you might have never heard about gold mining these days. The reason is that all U.S. mining is done by large corporate entities that process rock in northern Nevada. The deposit is known as the Carlin Trend. It's a 40-mile strip of low-grade gold. When I say low-grade ore, that's what I mean. If you hold a sample of the rock they're processing in Nevada, you cannot see the gold. If you ever find a rock where you can see the gold, you have a very high-grade ore on your hands. The gold of the Carlin Trend was deposited 350 million years ago at a time when Western North America was being sutured together. 2 tectonic plates collided, generating high pressures and temperatures that resulted in the hydrothermal emplacement of the gold in the Carlin Trend. This is known as a sediment-hosted gold deposit. How big is the Nevada gold boom? About $150 billion big. Almost 80% of the gold produced in the U.S. comes from the 30 or so mines operating in northern Nevada. As long as gold prices stay high, this operation may run until 2030 or so. And then begins the task of reclamation of the open pits. For the most part, the Nevada mines are open pit, and the gold is processed using acids to separate the gold from the crushed rock. The U.S. produces less than 6% of the world's gold. That puts us 4th behind China, which produces about 11%, and Russia and Australia that produce a little less than 10% each. Now let's talk about silver. Silver is probably the next valuable metal that you think of after gold. Silver is the 66th ranked element in abundance. It's about 30 times more abundant than gold. And silver has always been less expensive. During the Roman Empire, gold was declared to have 12 times the value of silver. In the United States, a value ratio of 15 to 1 was declared in 1792. After the gold standard ended, mid-20th century, the ratio became highly volatile, In 2011, it went as low as 30 to 1, while in 2020, it went above 120 to 1. Because silver is both useful and beautiful, silver has been mined for over 4,000 years for jewelry and coins. Silver has the best electrical and thermal conductivity of any metal, about 6% better than copper. This is why silver is used in circuitry, dentistry, and batteries, and electronic components. Silver also is used to stop the spread of bacteria, control odors, and prevent mold in treating wood. Silver shows up in the same type of hydrothermal deposits that gold does. When silver does occur with gold, it's usually in the form of an alloy called electrum, which ancient Greeks called white gold. As a result, silver and gold are commonly mined together, like in the Yankee Fork dredge operation. But silver also occurs in a number of other places besides hydrothermal deposits, and it is often mined alongside other minerals. For example, the lead-zinc mines in the carbonates of the Mississippi Valley will yield silver as well. The Red Dog mine in Alaska is the largest source of zinc in Alaska, but it is also the second largest silver producer in Alaska. About 50% of silver that's produced in the U.S. is mined alongside other ores. Although there are abundant supplies of silver, many people believe that the future of silver mining may lie in deep ocean polymetallic nodules. These are nodules that precipitate, forming slowly over time, and they contain economically viable amounts of copper, manganese, nickel, and silver, in addition to a number of rare elements. The attractive nature of polymetallic nodules is the concentration of the ores. The problem is mining those nodules without doing environmental damage to the oceans. As glamorous as gold and silver may be, they're not the most precious of metals. Platinum has been mined for over 2,500 years, but it is more scarce than gold and harder to access. Platinum is usually found in sulfide metal ores, but unlike gold, almost never in pure form. During much of the 20th century, platinum was also more valuable than gold, in part because more of the platinum is found at greater depth, while more gold has been found near the Earth's surface. Initially thought to be silver, the word platinum comes from the Spanish word for silver. In fact, there is a platinum group of 6 rare, naturally occurring elements that are known for their high melting points, chemical inertness, and of course, their beauty. The 6 platinum metals are platinum, palladium, rhodium, iridium, osmium, and ruthenium. Each of the platinum group metals has their own characteristics and varies in abundance. Geologically, the platinum metals form in different ways. Crystallization and settling in igneous complexes is one way. The Bushveld Igneous Complex in South Africa is a major supplier of platinum. Platinum group metals also show up in layered units of nickel, copper, and cobalt. Because platinum resists weathering, it also shows up in placer deposits. In fact, it was first mined as a placer. The platinum group metals are also formed by asteroid and meteorite impacts. The Sudbury mine in Ontario, Canada, is one of the world's principal sources of nickel and copper, but it also produces gold and platinum group elements. Sudbury's deposits are the result of an impact event that occurred nearly 2 billion years ago. The Sudbury impact ores suggest the possibility of going to asteroids in space and extracting rare metals there. But apart from when they are emplaced by asteroids, why are these dense, high melting point metals ever found anywhere near the Earth's surface? After all, when you learn about the Earth and Earth science, one of the first things you talk about is that the Earth is divided into a core, mantle, and crust. The core is predominantly iron, nickel, and other dense elements. The core formed during an early molten stage of the planet when differentiation occurred. The planet's heaviest elements settled to the center or core of the planet. So if differentiation occurred, then there shouldn't be any dense minerals anywhere near the crust today. And yet, there is an association with igneous rocks. It's a great geological question that really hasn't been explained. Another group of metals are somewhat misnamed rare earth metals, also known as rare earth elements. They are 17 soft, heavy metals that are difficult to distinguish in the field. They are actually more abundant than the word rare would suggest. The bigger problem is that they are not concentrated, meaning that the most efficient way to mine them is while mining something else as well. The rare earth metals have become increasingly valuable because of changing technology. Rare earths are used in many everyday items: DVDs, rechargeable batteries, catalytic converters, computer memories, and cell phones, and much, much more. In 1990, who had a cell phone? Now, everybody goes through a cell phone every 2 or 3 years. It's this kind of technology change that has made rare earth metals incredibly valuable. The batteries that are used in electric vehicles and hybrid electric vehicles use several pounds of rare earth compounds. As these types of vehicles grow in popularity, the availability of rare earth metals will become an important concern. Even more critical is the use of rare earth metals in military technology. For example, lanthanum is used in night vision goggles. Samarium is used in precision-guided weapons, and neodymium is used in laser range finders and communications. It's an important group of metals, and the rare earth metal used in the United States overwhelmingly comes from China, which in 2010 announced a threat to cut off rare earth exports to Japan until Japan gave in over an unrelated political dispute. Greenland is thought to have extensive rare earth reserves, but the exact amount is unknown. One reason Greenland has been eager for full independence from Denmark has been to have more freedom to exploit the island's rare earth reserves, which has also stimulated more U.S. interest in Greenland. And strategic considerations in the use of all metals are something that's on everyone's mind. The U.S. keeps a supply of metals that is known as the National Defense Stockpile. In that stockpile is a supply of about 100 critical minerals. The stockpile was conceived as supplying the nation's need for 3 years in a national emergency. In 2020, the stockpile was valued at around $4 billion. However, economically mineable concentrations of rare earths are hard to come by. The reason is that rare earths in mineable concentrations most frequently show up in relatively unique igneous bodies called alkaline igneous rocks. Alkaline igneous rocks are low in silica and/or low in alumina. These alkaline rocks make up less than 1% of all igneous rocks, and their composition varies quite a bit. The result is that the rocks that host the rare earth metals just aren't very abundant. Most of China's rare earths have come from a single ore at a single open pit mine in Inner Mongolia. There's another reason why China has become the predominant producer of rare earth metals. Rare earths are mined in big open pit complexes that require lots of processing of host rock. The rare earths are separated from the host rock through chemical processes which can cause health problems. Protecting workers processing the stuff is really complex. In a lot of ways, much of the world has been depending on China to produce the rare earth metals because we haven't wanted to deal with the multitude of problems associated with mining it. So what's the future of mining for precious metals? Nobody wants a hole in their backyard, although everybody wants or benefits from the precious metal that mines produce. It's really a difficult question to answer. Certainly, oversight is critical, and as commodity prices rise, larger set-asides for environmental protection can be levied and added to the profitability equation. The U.S. has moved to a mode where other countries take care of the mining and the environmental problems are temporarily out of sight and out of mind. But I haven't forgotten your gold mining adventures. One of the things I wanted to emphasize before we sign off on precious metals is that although you can pan for gold and find gold dust, you've got to keep the process in perspective. If it's done right, it can be a lot of fun and you may make some money. You just need to be watching out for the amount of sediment released into the stream, and you need to be careful in terms of your own safety around running water. But also, I want to emphasize that no individual with ordinary gear is going to get rich mining for gold or silver or platinum. Sadly, history is loaded with stories about people who have gone a little crazy attempting to find gold. Just do it for fun, and who knows, maybe you'll find a nugget or two to brag about.